Dear learners, before we understand the matter, first of all let us know what is the meaning of matter. What we eat, drink or breathe is the matter. Hence, all of us are surrounded by matter. Anything which occupies a space and have mass is matter. This is an important line. Learners should remember this. In order to understand the world better, it is necessary to understand the nature of matter. What is matter? Matter is anything which has mass, occupy a space. All solids, as we see around us, liquids, gases are made up of matter. A substance is a pure kind of matter having only one kind of constituent particles, either atom or molecule. All substances are matter, but all forms of matter are not. Now, let us understand the historical background. What is matter? Indian philosopher Canard and the Greek philosopher Lysippus and Democritus belong to this school of thought. The atom was coined by Democritus. Today, the idea of atom has changed since it was first proposed. The modern idea of atom originated with John Dalton in the year 1803. Today, we talk of two types of constituent particles, that is atoms and the molecules. Atom is a basic unit of matter and all chemical properties of matter can be explained on its basis. Molecules are important in explaining physical properties of matter like its melting and boiling points. Today, we talk of two types of constituent particles, that is atom and molecules. Atom is a basic unit of matter and all the chemical properties of matter can be explained on its basis. Molecules are important in explaining the physical properties of matter. Now, let us understand what is the state of matter. As we all know that the matter has three states, that is solid, liquid and gases. Matter can be classified in many ways. However, the following are the two main ways of classifying the matter. First, by the physical state of matter as a solid, liquid and gas, and the second by the chemical composition of matter as an element, compound or mixture. Water is the only substance which exists naturally in all the three states as shown in the figure. Solids. A solid has definite size and its shape which do not changes on their own. Suppose we take a stone or a duster or a chalk, it will remain as such, there is no change of their shape. In solid, the constituent particles are present very close to each other and the intermolecular forces operating between the constituent particles are very strong and they are capable of keeping the molecules in the fixed position. This is the reason why the solid has rigid and hard. In the same way, the liquids, a liquid has a definite volume. Liquids have properties intermediate between the solid and gases. The intermolecular forces in the liquids are weaker than the solid, but the stronger than the gases. Now, in case of gases, a gas occupies the entire volume of the container irrespective of their shape or size. In gases, molecules move freely because the intermolecular forces are very weak and are unable to keep the gas molecules together in a bulk. This is the reason why the gases are highly compressible. Due to high compressibility, CNG we all know compressed natural gas is used as a clean fuel for vehicles and in cooking, LPG liquefied petroleum gas as a gas cylinder in the kitchen we all see. Now, this table indicates the different characteristics of the three states of matter. You can see here The first column indicates the states of matter, solid, liquid and gas. Second, the volume. Third, density. Fourth one is shape, fluidity and the compressibility. If we compare the properties of these three states of matter, solid has fixed volume, density is obvious very high. The reason of density very high is that they have very strong intermolecular force of attraction that keep their particles very tight with each other, which causes its high density. Shape is also fixed. Fluidity, solids, we all know the solids do not have the fluidity, their molecules cannot flow like the water. And compressibility is negligible. Reason is, in case of solid, all the particles are very close to each other, they have very compact arrangement, and on applying further pressure, they cannot shift their position or they have the very fixed position. That is why they are negligible or they have very less value of compressibility or negligible compressibility. So, in the liquid also we all observe that it has a fixed volume, density is low as compared to the solid. Reason is, in case of gases, the molecular distance is little larger as compared to the solids, and shape of the liquid depends just depends on the shape of the container. When we put a liquid in a glass, its shape is like the glass. When it is kept in the beaker, its shape is like the beaker. So, its shape changes with the container. They have fluidity, they flow smoothly, and compressibility is very small because very less intermolecular spaces between the liquid molecules. In the same way, in case of gases, gases has no fixed volume. Reason is their compressibility factor, because we all know that the gases are very compressible. Density is obvious very low, because there is a very large space between the gaseous molecules, and has no definite shape, because if a gas is kept in different container, it will also get the shape of that container, that shape is variable. Flow smoothly like the liquids, and gases are highly compressible. That is why the reason is due to very large intermolecular spaces, their molecules can be further compressed. So, they have very high compressibility. This is the presentation that how the three states of matters convert into each other. This indicates that when a liquid is heated, it converted to gas. When gas is condensed, it is converted to the liquids. And as the temperature increases, the states of matter changes from solid to liquid and liquid to gases. It means, as the temperature increases, the intermolecular attraction decreases, which makes the molecules of the matter free, and ultimately at the very high temperature their molecules become totally free and they converted into the gaseous state. A pure solid turns to liquid at a fixed temperature, or in other words, conversion of pure substances from solid to liquid takes place at one particular temperature. This particular temperature is called melting point. Suppose we have taken a wax will, if we start heating, the wax will melt at the certain temperature, that is known as melting point. Similarly, when the liquid cools down, it converts into solid at a particular temperature. This temperature is called freezing point of that particular liquid substance. Suppose we have to take the water and it is kept in the freeze. It is not necessary that just after the putting the liquid into the freezer it will freeze, it will take time. So, at a particular temperature the water freezes to ice, and this particular temperature is known as freezing point. The temperature at which a liquid boils and it converted into gas is known as boiling point of the liquid. Our next topic is the elements, compounds and mixture. On the basis of their chemical nature, these states of matter are classified into elements, compound and mixture. A chemical element is a pure substance and it consists of one type of atom distinguished by its atomic number. Example of some elements are helium, carbon, iron and gold. Compound, on the other hand, a compound can be defined as a pure substance made from two or more elements chemically combined together in a definite proportion by mass. For example, glucose, glycerol, carbon dioxide. This represents the molecular diagram of the elements, compound and the mixture. You can say here that in case of elements there is only one kind of atom joined together. In case of compound there are two or more different kinds of atoms joined together to form a compound, and in case of mixture there are different types of elements, different types of molecules, all are randomly distributed and hence it constitutes the mixture. They are mixture of two or more pure substances. In this diagram we have shown the classification of the matter into the different substances which is represented here. Now, come on the next important topic. We generally this is the example we observe every day in our life. Suppose we are making glucose water or the nimbu pani, we do this type of exercises every day in our everyday life. This is known as a homogeneous mixture. Homogeneous mixture is a mixture where the substances are completely mixed together and have uniform composition throughout. For example, if you dissolve sugar or salt in water, you will see that after the complete dissolution of the sugar or water, sugar or you can say salt in the water, we are unable to distinguish where is the sugar particle and where is the water particles. So, if a solution is prepared in which we cannot distinguish the two components is known as homogeneous mixtures. There are some examples given in this table, different types of homogeneous mixtures. The examples are solid liquids, example is given here, liquid and liquid, gas and liquid, gas and gas, solids and solids. So, these are the examples we have mentioned here. Now, the another type of mixture is just reverse, heterogeneous mixture. A heterogeneous mixture, as the word indicates here, heteros means different. As definition also indicates, a heterogeneous mixture is a mixture where the substances, part or a phase remain separate and composition is not uniform. Very suitable example is, suppose you take 1 spoon soil or sand and dissolve into the water. You will see that after the dissolution, both the components, water and the soil or the sand, remain separated from each other and they constitute the heterogeneous mixtures. This table indicates the different types of heterogeneous mixture, and the most of these examples are related to our everyday life. For example, suspension, gel, emulsion, aerosol and foam are the different examples of heterogeneous mixtures. Now, we have just studied about the mixtures. Now, the another component is solution and its concentration. A solution made of solid dissolved in the liquid has two parts. These two parts are, the solid part dissolved is called solute and the liquid in which the solid is dissolved is called the solvent. For example, if we are dissolving sodium chloride in the water, sodium chloride will be the solute and the water will be act as solvent. The substances which is present in bigger quantities is normally taken as solvent, and substance which is present in the smaller quantity is normally taken as solute. Now, if we prepared the solution, we must also know what is the concentration of solution and how it is represented. Generally, the percentage of solute is equal to mass of solute divided by mass of solution into 100, that is represented the concentration of a solution, that is known as percentage concentration. A solution of 10% glucose by mass means that 100 gram of the solution contain 10 gram of glucose. This means 10 gram of glucose is dissolved in 90 gram of water. The concentration of a solute in a saturated solution at a definite temperature is called solubility of that solute in that particular solvent. Now, the next one is suspension. Unlike a colloid which contain smaller particles ranging from 1 to 100 nanometers, a suspension contains relatively larger particles. The size of particle in suspension is over 1000 nanometers. When fluor is added to water, it does not dissolve, but form a slurry, which we called a suspension. And this is the very good example you can perform at the home also. You can dissolve a little amount of fluor into the water, you will see the particles of the fluor remain suspended. However, if less amount of water is added in the fluor, 200 gram of fluor and 100 ml of water, we get dough to make the chapatis etc. Muddy water is an example of suspension. When a suspension is allowed to stand and it remain undisturbed, the dispersed particles settle down. Here the dispersed particle is the solute particle which we have added in the suspension. Now, after knowing the idea about the solution, their concentration and different types of homogeneous and heterogeneous mixtures, now let us understand, suppose we have prepared a mixture, how these components of the mixture can be separated. So, we will learn here in this topic separation of mixtures. All these separation techniques are based on difference in physical properties of the components present in the mixture, that is the physical nature of solute and solvent. Following two factors decide the best possible techniques to be adopted for separation. First is by the type of mixture, which type of mixture we are taking, and the component which you want to collect. Here is the few examples we will discuss, which is the separating techniques. Separation by using separating funnel. The mixture of two immiscible liquids, for example, liquid that do not mix, and oil and water, for example, is oil and water, can be separated by using a separating funnel. Suppose by mistake or mustard oil is mixed with the water. So, there is no other method by which we can separate the mustard oil from the oil. This is the only technique through which we can separate mustard oil from the water, and the apparatus used is separating funnel. Separation by evaporation. There are some types of mixture. For example, the separation of liquid solvent and solid solute from a solution is done by removing the liquid solvent by heating or by solar evaporation. In this example, water is volatile, but the solute particle is not volatile. That means, if we heat, only the water vapors will evaporate, only the water will evaporate, and the solid part, that is the solute, will settle down at the bottom because it is not volatile. So, if a mixture contain two types of component, one is volatile, another is non-volatile, we will use this method, separation by evaporation. Another method is separation by filtration. Sometimes we have to separate a kind of mixture. Suppose we have taken muddy water and we have to separate the mud particles from the water. Although we know that the mud is soluble in the water. So, in this method, filtration is a better method for separating solids from the liquid in heterogeneous mixture. In filtration, the solid material is collected as a residue on filter paper and the liquid phase is obtained as a filtrage, which is indicated in this diagram, and we will, here is also video also, we will see that how this process is carried out. And the basic principle of this method is only applicable if the two components, suppose the solid particle is miscible with the solvent and their particles are not completely soluble, that is the heterogeneous mixture. If the mixture is heterogeneous, this is the suitable method by which we can separate the solute and the solvent particles. Another method is separation by crystallization. Crystallization is the process of formation of solid crystals from a solution. The method of crystallization for separating solid from the liquid begins by evaporating the liquids. It means here the solid particles are not volatile, but the solvent molecules are volatile. So, on heating the solvent molecules get evaporated and the solid component, that is the solute, appears as the crystal. For example, we can separate the copper sulphate crystals from its solution, that is indicated in the crystallization process. This compound is copper sulphate. Separation by distillation. This is the most advanced method and the most technical method we generally use to separate the two components, and this method is known as distillation. The distillation is a process in which a liquid or mixture of liquid is boiled in a distillation flask. The vapor is condensed by passing through a water closed tube called condenser and collected as a liquid called distillate. Separation is based on the fact that the liquids will have different boiling point. So, the main principle of this method, distillation process, is if there is two miscible liquids having different boiling points, then we can use this method of separation, that is the distillation process. Another is separation based on magnetic properties. This is also a technique we generally use at our home also. Suppose we have to separate the sugar from the iron filling. Suppose by mistake the sugar and the iron fillings, one is magnetic component. The basic principle of this method is that in this mixture one component should be magnetic in nature, that is its particle is attracted by the magnet. The mixture of magnet and non-magnetic substances, the magnetic substances can be separated by using a magnet. For example, you will be able to separate iron granules which are magnetic in nature from the non-magnetic substances like the sand, sugar, sawdust, etc. So, this method is, the basic principle of this method is, if in a mixture, definitely we can say this is a heterogeneous mixture. In case of heterogeneous mixtures, they are in the solid state, and in both the two components one is magnetic in nature, then we will use the magnetic separation method.